Alright folks, hello and welcome to this video example on section 3.3, Systems of Linear Inequalities. So just as we looked at solving systems of equations, we'll now look at solving systems of linear inequalities. So the definition of a solution is very similar. It's the set of ordered pairs that satisfies all inequalities in the system. Okay, it's usually a shaded region, and that word all, let me underline it, is very important. It has to satisfy them or make them true. Now, with inequalities, you remember you're going to have dashed lines, solid lines, you're going to be shading, and it is recommended that you shade differently. So, for the solving procedure, let me say what I mean by that. You're going to graph all linear inequalities on one plane, but you might want to use either different colors, different shading, or like a different pattern that you use. You're gonna, and I'll show you a couple of tips when we look at some examples, but you're gonna want ways to distinguish which graph is which. Since if you don't know which inequality you're looking at, it's hard to tell what the final region is, what your final answer is. So here's the two-step procedure. It's to graph all of them, shading differently, whether that's with colors or a pattern. And then the second step is just to identify the region that's common to all of them. Alright, the solution has to make all the inequalities true. And if you happen to graph, and your final graph is messy or unclear in any way, you can use annotations. Okay, you can actually draw an arrow to a space and say, this is a dashed line. Okay, and make it very clear to the reader, even though there might be some messy marks on the page, that that's what's going on there. Alright, so we're going to look at a couple of examples. Alright, so let's get started with these two examples. In example 1, we have the instructions to solve this system. I'll just add a curly bracket there. And that's going to mean to find the region where all of those inequalities are true. So we'll start by graphing one inequality at a time. If you have different colors and you'd like to use those, that would be perfectly fine. So to graph x is greater than or equal to -8, we look to the associated equation x equals -8. And since it's a greater than or equal to sign, I'll use a solid line. And so x equals -8 is going to be a vertical line going through the point -8, 0. So I'll sketch it just like that. All right, there it is. And next we're going to look at this line. Y is less than or equal to -1, or that inequality. So we'll do y is equal to -1. We'll look at that horizontal line passing through -1. And since it's less than or equal to, it will be a solid line. Okay, just like that. And now let's talk a little bit about the shading of those two regions. For the first one, and you could shade, one at a time. I put the second line on there. If you want to shade one first before drawing the second line, that's perfectly fine. The first line was x is greater than or equal to -8. So that's this line here. And where are the x's greater than that line? And you got to think a little bit about x. And the x-axis, it moves left and it moves right. As you go right on the x-axis, as you move this way, the numbers are getting more positive and larger. As they go this way, they're getting less, they're getting more negative and smaller. So to the right is where we're going to want to shade, because that's going to be where x is greater than or equal to -8. So I will take the black marker here, and I'm going to shade in vertical lines left to right. As you can see, this can get a little messy, especially if you do it all in one color. Now let's look at the y is less than or equal to -1. That's this line here. And you just think, well, the y-axis, it gets less as you go lower. It goes more into the negatives, you get smaller numbers, and greater as you go higher. So where is y less than or equal to -1? Well, it's going to be below that line. And for this one, I'll use red. Though you could see there will be a crisscross forming just by using the two different colors, or using the two different patterns. So I'm shading below that line. Next up, we have y is less than -2x minus 4. So I will plot that line. There's my y-intercept down here at -4 or 0, -4. There's negative. And now with this line, it's going to go up 2 over 1. So that's up 2 over 1, up 2 over 1, be something like such. And oops, let's just fix that. It should be a dashed line, but I'll show you how you can annotate to fix that. Say you make it on there and it's just too messy to erase. We have that line graphed and we want to go less than that or lower than that, so I'm going to use blue and shade beneath that line. Okay, and now for the final answer, you just have to see where do these overlap, or where do these regions overlap? What area is shaded by all three? And hopefully you can kind of see that it's this section down here, this half plane, we call it, or this region, is shaded by all of them. So to help annotate this a bit, I would label this as my solution. I can write solution. And we're going to need an annotation because we don't have a dashed line on that. I'm going to draw an arrow and say this is dashed. Now, if you have time to erase or you're able to without making a big mess, it's hard to do on the computer, you can do that. But that's a dashed line, and then this line here is a solid line coming from the x equation. So if it's shown as solid, I don't need to annotate that at all. And that will be your solution to example 1. Now let's look at example 2. Here again we have a couple of equations, or inequalities. We want to graph the associated equation. This one we're going to graph y equals 3. So that will be the horizontal line going through 3. And we could put 0, 3 just to show that. And it's less than or equal to it, so we'll shade below that line. And next up we have an absolute value equation, which we practiced graphing in the last section. This y, or this x plus 4 here, well, remember we want to graph the associated equation, so I'll write it, x plus 4. And this is going to have a horizontal shift of 4 units to the left. That's indicated by that there. The new vertex of our absolute value function will be negative 4, 0 instead of 0, or instead of 0, 0. So if I start at the origin and I go 4 to the left, we get a vertex right about there. Oh, a little messy. And that is negative 4, 0. And that equation will have a slope of 1. Or the lines coming out of that equation will have a slope of 1, and it'll go up and to the right and up and to the left. This time I remembered to do the dashed line, so I'm not going to need that annotation. And we want to shade greater than that function, which is everything between the v, or all the way up here. It's going to be shaded or above that region because its y is greater than. And if you wanted, you could use a test point as well. And you should be able to see that your final solution is this area in here where both functions are shaded. But notice it is included on the top. The answer, the solid line above shows that that part is included, and the dashed lines show that that part is not included in the solution. If you want, you can label it solution. And that's how you would solve example 2. Now, I just want to make one more final point, and notice that all of these equations on this screen, except for the x, were in the form of y equals. That's going to make it easier to graph and to shade. So if you're given a standard form equation, yes, you can still graph. You might want to use a test point, but you can't use the exact same logic of above and below unless you have the y isolated. So my advice would be look back at the video from just graphing one linear inequality if you need some extra help with that, but isolating the variable first, especially y, is going to make these problems easier. Summarize what we did. So in both of these examples, or in this lesson, we looked at the procedure for solving, which is 2 steps. You want to graph all the inequalities and find the common region to all of them. And then we looked at 2 examples and noted that you can use different colors, or you can use annotations if you get a messy final answer to get your solution. Always make it clear. Make it clear to the reader, clear to the teacher, so there's no argument, oh, I kind of meant that this was shaded, I didn't mean that this was a point. Just make it clear. If you have to write a little extra, that's always best. And if you can put your equations in y equals, I'll just add a third thing, that's going to make your life easier as well. So that's our introduction to 3.3, and thanks for watching this video lesson.